Okay, I want to welcome you to this class. This is our very first class, and it is Artificial Intelligence Overview. We're going to be looking at artificial intelligence and trying to understand what it is and why do we even need to concern ourselves with artificial intelligence. Maybe briefly, if I can hear from you, could I hear someone tell me what comes to their mind when they hear the word AI? One, what is AI anyway, in your own understanding?
Hello?
Yes, please.
Okay. Thank you very much. AI, AI, artificial intelligence, I would think of AI being being whereby the computer can do things on its own. The computer can do things on its own, be it recognition, be it estimation, when it can do everything on its own without any help from the outsider. That's how I think about AI, artificial intelligence. Thank you.
Okay. Yes. Yes, please.
Yes. Yeah. So sorry, I didn't see where to put my hand up. So sorry. What I understand about artificial intelligence personally, like what he has also said, I'm just going to add on. AI works with data that it studies. You make the algorithm study the data so that it can be able to think, to learn, to communicate to you, as though analysis has been done by a human being, yet all that has been catered for by what the algorithm has been able to pick and learn over time.
Okay, thank you, Hope, for that
explanation. Someone.
Yes, Victor.
In my own thinking, AI is the ability of machines to be able to do work intelligently, like voice recognition, face recognition, and others, just to substitute what the natural intelligence can do. Thank you.
Okay.
Hello.
Yes, please.
Hello.
Yes, go ahead. Go ahead. Okay, I think I will lastly hear from Mugasha.
Hello.
Good evening.
Yes, Mugasha.
According to me, I think AI is the ability of a machine to mimic human intelligence and solve problems just like a human would do, based on the data it is trained on, based on the data it's trained on. Yeah.
Okay, thank you all. For those of you who have raised your hand, I'll come back to you later on. We're going to have so many questions like those ones. And thank you for those who have been able to share their views. So we want to come here and understand that mankind is welcoming the fourth industrial revolution. You all know that the fourth industrial revolution is already here, represented by intelligent technology. And the keyword to note here is intelligent technology. New technologies such as AI, Internet of Things, let me highlight AI here, Internet of Things, 5G, and bioengineering are integrated into all aspects of human society, driving changes in global micro trends such as sustainable social development and economic growth. New kinetic energy, smart city upgrading, industrial digital transformation, consumer experience, etc. etc. So as the world's leading provider of ICT information, that is information and communications infrastructure and smart terminals, Huawei actively participates in transformation of artificial intelligence and proposes Huawei's full scenario AI strategy. And this chapter mainly, we will introduce AI overview, technical fields and application fields of AI. Where is AI applied? What are some of those technical fields? And also we shall look at Huawei's AI development strategy, AI disputes future prospects of AI. How will artificial intelligence look like in the coming few years? The objective of this course, upon completion of this course, you'll be able to understand basic concepts of artificial intelligence. You understand AI technologies and their development history, understand the application technologies and application fields of artificial intelligence, know Huawei's AI development strategy, and lastly, look at some of the development trends of artificial intelligence. Now let us look at the AI overview. We all know that in the wave of internet development, the emergence and rise of artificial smart, which people usually call AI, is undoubtedly an extremely important part. Today, AI continuously is syncing technology, which is embedding itself in almost everything that we use, which is connected to our human life. Since the 1950s, with the development of related fields and the leap of software and hardware conditions, artificial intelligence has been applied on a large scale in a nearly decade after several ups and downs. There have been so many trials, so many things which have failed, but then there have also been some major successes as far as Huawei is concerned. So we're going to look at this and try to understand briefly about what AI is. So, artificial intelligence in the eyes of the society. I've just listened to you, and this is how people look at AI. Most of us to date, or even when we are growing up, we got to know artificial intelligence through news. You're watching news, maybe there's a technology section and you get to know about artificial intelligence. Some of us through movies. There's so many interesting movies about artificial intelligence. The one being popular like the Terminator, where we looked at that machine that was reasoning with human beings and had the intelligence of human beings and being able to fight with humans, but also popular movies like The Matrix, like Robot, Blade Runner, etc. and etc. All those movies, give us their, understanding of what artificial intelligence can do or what it could actually do. Someone is saying Mr. Robot. Yes, Mr. Robot, if you haven't watched it, you can also take on some time and watch that movie. So, and also most of us get to know artificial intelligence through our actual applications in our daily life. We use so many applications today, and because we are using those applications, some of us even do not notice that it's actually artificial intelligence. So what is artificial intelligence in the eyes of the public? If I could maybe throw that question to you, what is artificial intelligence in your eyes? Some of you have already told me what you think it is, but when someone mentions artificial intelligence, what comes to your mind? Joshua, you want to say something?
Virtual assistants.
Okay, Michael says virtual assistants like Siri, like okay, Google. Even so, some time back, MTN had a very viral advert about Uncle Google, sir, and people talking to it, not understanding clearly that it is actually artificial intelligence behind the algorithm, behind all that. Yes, Gasha, your hand is up.
What? Smart homes.
Smartphones, okay. Joshua, your hand is up.
Smart homes.
Smart homes. Yes. Please turn on the lights, the TVs, and everything connected together, and subjective to your commands. Yes, Joshua, your hand is up. All you had said.
For me, it is a simulation of human intelligence processes by a machine.
Okay,
simulation.
That's okay. Hope you can say something. I'm seeing your message in the chat. You're saying that you want to say something.
I want to say like how I've been interacting with it in my daily lives and some of the things that I've done. One of them is disease mapping. Can I say 3 or 4? Oh, it's fine to say one.
Please go ahead.
Yeah, one of them is disease mapping. We are using it a lot or like in some of the things we are doing. Then also autonomous vehicles, where the vehicles, self-driving vehicles. Then also natural language processing, and social media monitoring.
Okay. Thank you, Hope, for sharing.
Like I wanted to see what I'm used to, what I see every day we are using at our workplace.
Okay, that's okay. That's okay. Thank you. Thank you. So as you can see, we have some of us, maybe intentionally or unintentionally, one way or another, we have, played with artificial intelligence or even used some of those things. And I was even paying attention that actually we are using some of those things to date. I'm happy, Hope, that you're using some of these technologies at your workplace. Keep it up, and we hope that you'll be able to, come up with solutions to our African problems. Like I said in the news, basically, usually the news talks about AI application, the industry outlook, the challenges faced by AI. Sometimes we see exaggerated titles, that are used to report artificial intelligence. And let me just close this Telegram just a moment. Tired of these notifications. Just quit it. Okay. All right. Sorry about that. And then also movies. We talked about movies. Many of you told us some of your favorite movies that you watched that had artificial intelligence, and with movies, virtual artificial intelligence was built with rich imagination. Most of these movies, they have rich imagination, and also our application in our daily life. We have artificial intelligence makes life more convenient while bringing privacy concerns, of course. We have security protection, entertainment, smart homes, finance, etc. and etc. So this is artificial intelligence and how we have interacted with it from the different aspects of our life. And let us try to understand a few things, about artificial intelligence and how some people have been able, some scholars or researchers have been able to define it. Basically, if they're talking about artificial intelligence and they're trying to understand what artificial intelligence is, we all know that the branch of computer science concerned with making computers behave like human beings, it is one of the popular definition of artificial intelligence, and it's an early definition in this field proposed by John McAfee at the Dartmouth conference in 1956. But this definition ignores the possibility of strong AI. We're going to later on look at what is strong AI and what is weak AI. We're going to see the difference between the two. And according to another definition, artificial intelligence is weak AI demonstrated by artificial machines. And we shall be able to also understand what weak AI. Alan Turing discussed the question of can machine think in a seminar paper, Computing Machinery and Intelligence. So these are some of the popular scholars. Alan Turing in 1950 said, I propose to consider the question, can machines think? And this is how he was trying to define artificial intelligence. John McAfee in 1956 said artificial intelligence is a branch of computer science concerned with making computers behave like humans. And then Marvin McKinsey says that the science of making machines do things that would require intelligence if done by men. These are some of the definitions by some of these researchers and scholars. So let us now look at what artificial intelligence is. But before we look at artificial intelligence, let us also first understand what SMART is before learning what artificial intelligence is. Let us first try to understand what it is. What is intelligence? Let's first understand what SMART before learning AI is. And according to the theory of multiple SMARTs, humans, SMART can be divided into 7 categories. We have some of them, Hope mentioned them before in some of the fields where she has applied artificial intelligence. But the first category is verbal or linguistic. Another category is logical mathematical, visual spatial, bodily or kinetic, and then musical. we have interpersonal, and we have personal or introspective. And we want to understand what are some of those things are. Let us look at verbal or linguistic, the language intelligence. It refers to the ability here. I don't know if they explained them later on here. I don't think they did. If they didn't, let us just go through them just briefly. Here, the language, intelligence. Maybe if someone has an idea about it, before I talk about it, you can go ahead and say mic check, and then tell us what you know or what you think about it. Yes, please.
Verbal intelligence refers to the ability of a machine or a computer-aided device to be able to differentiate between different languages or to understand what is meant in that language. Let's say like Google Translator, or if you give a command and then the device responds. Thank you.
Very well explained. I'm not going to even talk about it. Now let us go to logical or mathematical. Anyone? You can say mic check and speak to us. Thank you, Romeo.
Mic check.
Go ahead.
I think you can use supercomputers that are able to solve very complex mathematical problems that would take humans a long time.
Okay, thank you. How about visual?
Okay, visual is where, let me give an example. For example, let me use an example of South Africa. Like there is a lot of apartheid even in that they're building housing. So you can just use the machine to detect where all the and the areas, also street lights, also light. The computer detects the night light so that it can be able to detect the housing standards of people or the economic status of people just looking at how the imagery is.
Okay.
How about mic check?
Yes, Joshua. Thank you, Hope.
It's Michael. Visual. What about Face ID? Like on the iPhone, it can adapt when you have a mask, when you have glasses. You know, it learns the different visual movements of your face and everything.
Okay. Thank you all for sharing. How about bodily?
Mic check. Bodily movements. For example, there is a smartwatch called a Fitbit, and then there is the Apple Watch. They track your movement, heart rate, and everything. And they plot ECGs and other graphs to help you maintain your health.
Okay. Thank you. How about musical?
I check.
Go ahead.
With musical, there is an intelligent software that I have interacted with, and this kind of software detects, it is mostly used in the clubs. It detects the beats like in the background, and then it changes the lights according to the beats. Something like that is an example of it. It detects the way the sound plays and it responds. It tries to, I fail to understand, to explain
Mic
it out.
check.
Hello, Mike.
Thank you for trying. Yes, go
What
ahead.
of Shazam?
Even
What of
Shazam.
Shazam?
Okay, very
Yes.
good example.
Shazam. And I was also saying that we could also talk about the fact that, for example, when you go to, let me talk about Spotify. If you've always been clicking on some random on a given type of music, when they bring for you recommendation, they will always bring for you a recommendation of that type of music, hoping that for you like that kind of music. It would be both musical and logical, I think. Thank you.
Okay, thank you. How about interpersonal?
Hello?
This is like where you chat. Hello, mic check.
Yes, Hope.
Where like you chat with maybe with a chat bot, thinking you're chatting with a human being.
Yeah.
Okay.
I think interpersonal intelligence comes in when, like, for example, the dating apps where different people are matched due to their preferences by an algorithm within the app.
Okay. Yeah. And also, we also looking at things like people's moods, emotions. Have you heard of Sophia and feelings, and be able to discern and respond appropriately to some of those words that you use when you're relating with other people?
Yeah.
How about intrapersonal?
Hello?
Yes, go ahead.
Mic check. What about intrapersonal? Intrapersonal, I don't know. what about the driving cars?
The self-driving car. Some of those technologies use a combination of these things. You realize that they use a lot of logical, they use a lot of visual, right? To be able to read what's before them and make calculations. So they use these things. Yes, please.
I think the intrapersonal is best is generalized on the idea of a smartphone where it completely knows you and studies everything about you, even when there is advertisement. It's targeted due to the data you enter into your smartphone.
Okay, thank you. Now we shall move on to the next slide and try to understand what artificial intelligence is. I'm not going to ask you again because I've already asked you before and you have told me very interesting things about artificial intelligence. But here they're telling us that artificial intelligence is a new technical science. When they say new, it doesn't mean that it happened last year or the year before or just in the previous 5 years, but it's a new technical science that studies and develops theories, methods, techniques, and application systems for simulating and extending human intelligence. Keyword: simulating and extending human intelligence. In 1956, that is some while ago, the concept of artificial intelligence was first proposed by John McAfee. We have already looked at that, who defined the subject as a science and engineering of making intelligent machines, especially intelligent computer programs. Artificial intelligence is concerned with making machines work in an intelligent way similar to the way that human mind works. At present, artificial intelligence has become an interdisciplinary course that involves various fields. People in statistics are using it, people who are working with databases, data mining, machine learning, artificial intelligence, pattern recognition, neural computing. So many different concepts are also using artificial intelligence. When you even go to the health sector, still many of those people are still using artificial intelligence. Machine learning, on the other hand here, machine learning can be understood from multiple aspects. And machine learning scientists provided a widely quoted definition that goes by a computer program is said to learn from experience, which they term as E. We shall look at these things in detail later, with respect to some of the tasks at hand, which they define as T, and performance a measure which they defined as P, and if and performance measure. So this improves with experience. So for them to keep on measuring, the more experience the program has, the more it learns, the more it becomes better. And we shall look at machine learning. I think it's our third chapter. We shall be able to understand. But as we deepen our understanding of machine learning, we'll find that connotation and extension of machine learning are changing over time, because a variety of fields and applications, they are involved in machine learning, and it develops rapidly, and it is not easy to define machine learning simply and clearly. In general, processing systems and algorithms of machine learning are an identification mode that performs prediction by finding a hidden mode in data. Machine learning is an important subfield of artificial intelligence, which also intersects with data mining and knowledge discovery in the database, the KDD. So this is artificial intelligence, and we can see we can use artificial intelligence as our knowledge base for most of these, fields: logic, linguistics, philosophy, computer science, brain science, cognitive science, and psychology at large. So let us move to the next slide and try to understand the relationship between artificial intelligence, machine learning, and deep learning. So we already say that machine learning is specialized in studying how computers simulate or implement human behavior, right? Basically, we are looking at how they are going to study and learn and simulate human behavior. And they do this by acquiring knowledge or skills. You train your computer or you train your program to simulate human behavior. And yet the concept of deep learning originates from the research of artificial neural networks. I think Hope will explain to us what neural networks are. So it comes from the research of artificial neural networks, whereas deep learning is a new field in machine learning that simulates the human brain to interpret data such as images, sounds, and texts. So among the three, these here we have that human artificial intelligence, machine learning, and deep learning. We are saying that among those three, machine learning is a way or a subset of artificial intelligence. And deep learning is a special type of machine learning. So deep learning is a special type. It is a type of machine learning. And whereas we said machine learning is a subset, right? It is a way of achieving artificial intelligence, or it is a subset of artificial intelligence. So I want you to draw that distinction from there. AI can be compared to the brain. You can compare AI to our human brain and how it functions. So machine learning is a process of mastering cognitive capabilities, whereas deep learning is an efficient, teaching system in this process. So deep learning is more like, how you go to class and they teach you how to do things, whereas machine learning is actually you taking the initiative to study those things and make sense out of them so that you can achieve intelligence. And in this case, we're looking at artificial intelligence. AI is the goal and the result of all these other things. When we are having deep learning, machine learning, our end goal is to make sure that we achieve artificial intelligence. Deep learning and machine learning are methods and tools that we can use to come up with artificial intelligence. We said before that AI can be classified into strong artificial intelligence and weak artificial intelligence. And we shall be looking at some of those things later on. Still continuing to explain the difference between AI, machine learning, and deep learning. We see that AI, it is a new technical science that focuses on the research and development of theories, methods, techniques, and application systems for simulating and extending human intelligence. Whereas machine learning here, it is a core research field of artificial intelligence. As you can see, we said it can either be a subset or a way of achieving artificial intelligence, and it focuses on the study of how computers can obtain new knowledge or skills by simulating or performing learning behavior of human beings and reorganize existing knowledge architecture to improve its performance. It is one of the core research fields of artificial intelligence. When it comes to deep learning is a new field of machine learning. And the concept of deep learning originates from the research of artificial neural networks, the multi-layer perception, and it is a type of deep learning architecture. The deep learning aims to simulate the human brain to interpret data such as images, sounds, and text. Basically, with deep learning, they're trying to emulate and see how does a human brain function, how does it interpret things, and how does it, send instructions to the different, organs to act upon, the data that has been, processed in the brain. So there are three major schools of thoughts. We have symbolism, and we are going to look at another one after symbolism. And after looking at symbolism, we shall also go ahead and look at the third school of thought, which will be, I think, behaviorism. So we have symbolism, We have from symbolism, we have connectionism. From connectionism, then we have behaviorism. So we shall be looking at those things shortly after, but let us now look at symbolism and try to understand what symbolism is. So the basic school or the basic thoughts, what people think of, what people, that's the three schools of thought: symbolism, connectionism, and behaviorism. The basic idea of symbolism is that the cognitive process of human beings is a process of interface and operation of various symbols. A human being is a physical symbol, and so is a computer. A computer, therefore, can be used to simulate intelligent behavior of human beings. The core of artificial intelligence lies in knowledge presentation, knowledge interface, and knowledge application. Someone presents you with a knowledge. You are in this class, you are being able to, be presented with knowledge. After they present knowledge to you, you are able to represent that knowledge, or you're able to, understand that knowledge, and later on you'll be able to apply that knowledge. And that is what they call intelligence. So knowledge and concepts can be represented with symbols, and cognition is the process of symbol processing, while interface refers to the process of solving problems by using knowledge and such. So symbolism lies in interface symbolism, interface, and machine interface. So the basic thoughts: we have cognitive process of human beings is a process of interface and operation of various symbols. Basically, before we proceed, can someone tell us what is the meaning of cognitive?
Using the brain, use of the brain.
Use of the brain, thank you. Anyone with a divergent view? Our literature scholars?
Understanding.
Understanding.
And reasoning.
Reasoning. Okay, thank you. So a human being is a physical symbol, and so is a computer. I have talked about this, and computers can be used to simulate intelligent behavior of human beings. The core of artificial intelligence lies in, representation, knowledge interface, and knowledge application. Someone is going to, present the knowledge to you. You're going to interface the knowledge, and then you're going to be able to apply the knowledge. So representative of symbolism interface includes symbolic interface and machine interface. Let us look at the next major school of thoughts, which is connectionism. With connectionism, it is the basic idea of or the basis of thinking in neurons rather than the process of symbol processing. Human brains vary from computers, that we all agree. And a computer working mode based on connectionism is proposed to replace the computer working mode based on symbolism. The basic idea of connectionism is that the basis of thinking is neurons instead of symbolism processing. Human brains vary, and we said they do not work like our human brain or the way our human brain works. The concept is represented by specific activation mode of the entire network, and each node without specific meaning plays its role in the representation of the concept. So maybe you can go ahead to better understand this and try to read about how the human brain works and how it processes data and how it sends instructions and how it learns. For example, in symbolism, the concept of a cat may be, represented by a cat node, right? And all a set of nodes representing the cat attributes, such as for a machine to be able to understand a cat, it has to have maybe, let's say, it has to have claws, it has to have 2 eyes, it has to have 2 legs, and it has to be fluffy, right? It has to be fluffy. So, and the moment someone sees those identification, then that is a cat. However, in connectionism, each node does not represent specific concepts. So it is impossible to find a cat node or eye neuron in connectionism. So connectionism is basically based on neural networks and deep learning. That is how connectionism works. It is basing on neural networks and deep learning. An apple in the eye of connectionism. You have an apple and there are different attributes to it, which now will lead to an apple. So that is connectionism. And we want to look now at the third school of thought, which is behaviorism. And intelligence depends on perception and action. How do you perceive something? When this happens, what do you do? The perception action mode of intelligent behavior is proposed in this third school of thought. Intelligence requires no knowledge, representation, or interface. Artificial intelligence can evolve like human intelligence. Intelligence behavior can only be demonstrated in real world through the constant interactions with the surrounding environment. When it starts raining and you have an umbrella, what do? Do you keep it in your bag, or you get it out and put it on top of your head to shield yourself from the raindrops? Or how do you adapt? How do you perceive your environment? So representative of behaviorism, behavior control, adaptation, and evolutionary is a third school of thought. And many scholars prefer this school of thought because they believe that the computers will also be able to evolve just like the way human beings also go ahead and evolve. This is the brief history of artificial intelligence. We're not in an history class, so we're not going to pay a lot of attention here and cramming years and dates of when things started. And this material, these materials were already shared, but you can go ahead and read through them and try to understand. But you can see AI started as early as 1956 when it was proposed at the Dartmouth conference. You can see 1959, Arthur Samuel proposed machine learning, and there's a detailed explanation of all these milestones. I'm not going to go through them, but for you to better understand how far we have come as far as artificial intelligence is concerned, you can always go back in the material and visit it and have a better understanding of how far we have come here in the 2020s. Let us look at an overview of artificial intelligence or technologies. What comes to your mind when you hear the word technologies before we look at the technologies themselves?
I understand as latest ideas to solve problems concerning society.
Thank you, Mariam. Thank you so much. Anyone with a divergent view?
I think technology is an aid that helps us open another world within ourselves.
Open another world within ourselves. Okay, so AI technologies are multi-layered and covering the application, algorithm, mechanisms, tool chain, devices, chips, processes, and material layers. These are some of the layers, and we will get an opportunity to talk about some of these layers later on. But as you can see, the device, we're looking at the new computing device, bionic device, or the high bandwidth off-chip memory. When it comes to the process technology, we have the on-chip, CMOS process technology, new process technology, AI-related technologies in our view, and we said they are layered. So as you can see, we have the layer, application layer, we have the algorithm layer, we have the device layer, we have the chip layer, and the process layer. And this is the the image that is showing them as a multi-layered technologies covering the application layer, algorithm, mechanism, tool chain, device, chip, process, and material layers. In application, we have things like voice, speech, text control, whereas when it comes to algorithm, we have machine learning, deep neural networks, and when it comes to the chip, we have algorithm optimization chip, programmable chip, and neuromorphic chip. So the rapid development of application and algorithm, especially deep learning and convolutional neural networks, raises performance optimization requirements for artificial intelligence chips by 2 or 3 orders of magnitude, which has triggered the upsurge of AI chip and R&D or redistribution and in the recent years. On the other hand, the rapid development of new materials, processes, and components such as 3D stack memory and processes, 3D printers, also make significant improvements in performance and power consumption of artificial intelligence chips. There are companies that are dedicated to manufacturing these chips. So the driving force comes from breakthroughs in basic research. In general, the above driving forces empower rapid advancement of AI chip technologies in recent years. So we have these applications. We have the application layer, and here we look at things like, video and image, where you look at facial recognition, etc., etc. We have voice recognition, voice wake up, voice fingerprint. When you talk to Siri, or you talk to Google, or you talk to Bixby by by Samsung. So all these fall under the application layer. When it comes to the algorithm layer, we already say that we look at things like machine learning and neural network. And neural network interconnection structure looks at the multi-layer perceptron, or the convolutional neural network, the CNN, and we have looked at the MLP, which is the multi-layer perception. And then we have things like the recurrent neural network, the RNN, and some of these terms we shall be able to discuss later on. We also have the deep neural network. We have the network algorithms and machine learning algorithms that support vector machines, the SVM. So we shall look at some of those things later on. And now we have the chip layer. When it comes to the chip layer, so the chips basically look at optimization or algorithm optimization, and this is why we look at the optimization chip. And when you hear the word optimization, basically we are looking at efficiency and low power consumption. So we are looking at some of those things. We also have the neuromorphic chip, like the bionic brain, the biological brain inspiration, the brain mechanism simulation. These are some of the chips that were developed. We also have programmable chips that are developed considering flexibility, programmability, also algorithm compatibility and compatibility with general software such as the digital signal processing, the GPUs, which are the graphic processing unit, and field programmable gateway array. And we have also other, related, chips that are in the chip layer. When it comes to the device layer, we are looking at the high bandwidth of chip memory, like the HBM. The HBM is the high bandwidth memory. We also have the DRAM, which is the dynamic random access memory, high-speed graphics double rate, etc., etc. I'm not going to talk about many of them, but when you get an opportunity to go through the material, you can be able to see some of those things. In the process layer, like you hear the word process, we're basically looking at the processes, and we have the chips that are going to help us, deal with processing, like the ReRAM, like the CMOS, multi-layer integration, and etc. So we shall look at some of these things in detail, and let me now move to the types of artificial intelligence. Now, artificial intelligence, I've told you before that we have strong AI and we also have weak AI. And by weak, we actually don't necessarily mean that it is weak, but it's a type of artificial intelligence, and we're going to try and understand why we are calling it weak AI. Okay, so let us look at the types of artificial intelligence. Here we have strong AI. Strong AI holds that it is possible to create intelligent machines that can reason and solve problems. As long as they apply reasoning and also solve problems, then this is considered to be strong artificial intelligence. Such machines are considered to be conscious and self-aware and can independently think about the problems at hand and work out optimal solutions to those problems, have their own system of values and worldviews, and have all the same instincts as living things, such as survival and security needs. It can be regarded as a new civilization in a certain sense. So this is what we're calling strong AI. A key count of artificial intelligence is to achieve superhuman level in challenging fields through self-learning without a prior knowledge. Most of the things we have in artificial intelligence that we have prior knowledge and machine learning, we teach the machine to learn the things that are taking place in the environment. So when we are looking at strong AI, we are looking at something that can reason, and also be able to solve problems. So strong AI can compete with humans in all aspects, and therefore it aims to enable robots to think, make plans, solve problems, perform abstract thinking, understand complex concepts, and also quickly learn from experience. And currently it is believed that if we can simulate the human brain and copy all its neurons and synapses on the same scale, then strong AI will naturally occur. So if you can emulate how the human brain works and transfer that same technology to the computers, then you can simulate, we can achieve strong AI. Now let us, currently we are in the weak AI phase here. That's why I said it's not really weak, like you hear the word weak, because most of the things we have seen today are under weak AI. And weak AI holds that intelligence machines cannot rely reason and solve problems. These machines only look intelligent but do not have real intelligence or self-awareness. If you did teach it something before and it doesn't have it in its algorithm, it cannot be able to reason and be able to solve that problem. If you introduce it something new, it is hard for it to adapt and reason out that something. That's why it's being called weak AI. The emergence of weak AI alleviates human intellectual labor, similar to advanced bionics. Both AlphaGo and robots that can write press releases and novels fall in the weak AI phase because they are better than humans only in some ways. The roles of data and computing power are self-evident in the era of weak AI, and they promote commercialization of AI. In the era of strong AI, these two factors are still critical. At the same time, the research of quantum computing by technology giants like Google and IBM also provide powerful support for humans to enter the era of strong AI, or strong artificial intelligence. Classification of intelligent computers. Let us look at some of those classification of strong intelligent computers. We have currently there's no unified definition of artificial intelligence research, and intelligent robots are generally classified into the following 4 types. We have thinking like a human beings. This is weak AI, such as Watson, the robot, such as AlphaGo, and also there's a robot called Sophia. So acting like human beings, weak AI, such as humanoid robot, iRobot, Atlas of Boston robot, and also still Sophia falls into this. And also thinking rationally, which is strong AI. Currently, no intelligent robot of this type have been created due to the bottlenecks in brain science. Acting rationally is strong AI, being able to act rationally. Something new, they have not taught it to you before, but you adapt to the situation and are able to find a solution to that problem. So this is what we are looking at, and these are some of the classification of artificial intelligence. Now let us look at artificial intelligence industry ecosystem. What time is it? By the way, I need to be okay. We shall have a break at exactly 7:40, and then we shall come back at 8, and then we complete the rest of the class. So we have our break at 8 at 7:40. That is 1940. So we're looking at the 4 elements, or we're looking at the industry, ecosystem, the AI industry ecosystem. The 4 elements of artificial intelligence are data. Let me highlight data, algorithm, computing power, and scenario. To meet requirements of these 4 elements, we need to combine AI with cloud computing, big data, Internet of Things to build an intelligent society. So you have here the AI application. Where do we apply AI? Already Hope told us they apply it in their healthcare. Where else do we apply AI? Can I hear someone talk to us and tell us?
Security industry.
Entertainment.
Security industry, yes. Someone said entertainment. You can also tell us how. So people who don't have an experience of how that can be applied can understand some of those things.
Hello?
In entertainment, you can use AI in virtual reality and mixed reality.
Okay.
Hello?
Yes, please.
Hello?
I hear you.
Yes, AI can be used in agriculture, for example, in crop monitoring, and then also crop disease monitoring. Okay, we can also classification of crops, and yeah, that's it.
Okay. All right.
Hello?
Thank you. Yes,
Hello?
please.
Yeah, it also can be used in businesses to predict like business stock prices and exchange. Yeah.
Okay.
Okay.
Yes, Hope. You're saying something?
Yes. Okay. Let me first mute myself because I'm. Okay, let me give my example. Sorry, I was talking to someone. Sorry about that. Yeah, the other example of what AI, like, let me give an example. Everyone knows COVID. Okay, you can also you can also use it like to detect the different how the lungs look, and then you get to know the case of COVID which someone has by just using artificial intelligence. And also like the outbreaks of fire, like in the case of pandemics, you can maybe if there are fires, maybe widespread fires, if you have an AI algorithm that monitors forests, you can get to know where the fires are. If also you have also been monitoring the forest, you can also detect and get to know the deforestation rate, or where the deforestation is currently happening, just using by AI. I think maybe, yes. It's a lot. Let me just mute myself.
Okay. Yes, Aisha, you want to say something?
It can be used in the restaurant and hospitality sector, whereby we can have robots do most of the work, the cooking, the serving, and moving around the tourists, so on.
Thank you for sharing. Aisha is my colleague from MOBS. Happy to see you on the forum. We see in the chat, a team also says that there are many ways agriculture is adapting to AI because they monitor a lot, for example, the weather, crop growth, etc. Okay. Okay. All right. So in agriculture, I think someone explained that. In retail, education, like detecting plagiarism, people who have submitted similar work, and etc. And so many even other ways where you are taught by a robot, and you go through a lesson and study, and just a robot at the end of it all. But for you to be able to achieve all this, there are some underlying infrastructure and technologies that you build on for you to be able to achieve up there. Things like the infrastructure, like the internet, like the sensors that you have on your smartphone or in your smartwatch, or the different devices that you have in your home, and of course the Internet of Things devices like the smart TVs, like the the smart cameras, the smart fridges, etc. and also server high performance chips that give us cloud computing powers. Here, this leads to big data. This leads to cloud computing. I know there are some big data courses taking place and some cloud computing courses taking place. I want you to interest you to try, and if you have not yet done this, to try and do them so to have a better understanding of how this works. And yeah, so all this after we combine and get computing power, and then here we get data. So after we have collected all the data from these devices, from the internet, from the sensors, Internet of Things, and we have big data, we provide this data to come up with algorithms, which we are going to use the computing power to process them. And then we can use technical direction like a computer vision, if you're going to do like, let's say, recognizing or speech, Google Translate, NLP, planning and decision-making systems, and also big data analysis. So the subfields of AI, we have subfields like computer vision, neural language processing, speech processing, machine learning, data mining, knowledge engineering, and we have talked about some of these already. And then we have robots, we have computer graphics, multimedia technology, database technology, visualization, information retrieval, and recommendation. This is the AI development report, and there are some of the subfields where artificial intelligence has been used. Now let us look at the technical fields and application of artificial intelligence. So these are some of the technical fields and application of artificial intelligence. We have our algorithms, which we use like, let's say linear, like logistics, like regression, and we use this to, come up with some of these research methods, schools like symbolism, we already talked about it, behaviorism or connectionism, Bayesian, evolutionarism, some of these things, but we'll get an opportunity to understand them. And then areas of artificial intelligence, robotics uses a lot of artificial intelligence, computer vision as well, knowledge extraction, intelligence, adaptive learning, planning and optimization, expert systems, etc. Areas of AI application, these are the technologies. Now, how do we apply AI? We have already talked about smart cities, digital government, autonomous driving, smart healthcare, smart education, smart finance, and smart manufacturing. These are some of the areas of fields where we can apply AI. So the distribution of AI application technologies in enterprises inside and outside technology. China, this talks mostly about China, but at present, application directions of AI technologies mainly include computer vision, and computer vision is basically a science of how computers see. The ability for computers to see and recognize things is computer vision. Then the second one, this is the first one, the second one is speech recognition, and it's a general term for various processing technologies used to research the voicing processes, statistical features of speech signals, speech recognition, machine-based speech synthesis, and speech perception. And then the third one is a natural language processing, the NLP, a subject that uses computer technologies to understand and use our natural human language. So those are some of the three areas that are mainly used in the application of artificial intelligence. So we have voice, we have vision, and we have the natural language processing. And to be able to use this, we use some kind of basic infrastructure. And so this is inside China, this is outside China. So the distribution of AI application technologies in enterprises inside and outside China, this is how people be able to use it. The blue is the voice. As you can see inside China, about 22 either individuals or enterprises use voice, or speech processing, artificial intelligence, and outside China, about 13% of those do that. When it comes to vision, as you can see inside China, about 46%, so the people using artificial intelligence use computer vision, and about 40% outside China uses technologies. And then it comes to natural language processing, 19% is in China, and then about 28% is in China, and then the other percentage falls under other basic infrastructures. So moving to the next slide, we have 2 minutes to our break. I think this will be our last slide. Let us look at voice processing application scenario. Many of you have dealt with this application scenario before, isn't it? Maybe by show of hands, can I just hear people who have interacted with this application scenario before?
Yeah, like me, maybe I can say the Google Assistant. Like in my phone, I can just speak and it's like I say, call mom, and before the guys calls mom.
Okay. Yep. Or you can. Very, very true.
Okay.
So things like Google Assistant, Siri, all these fall under voice processing application scenarios. And the main topics of voice processing research include voice recognition, voice synthesis, voice wake up, voice fingerprint recognition, and audio-based incident detection. Among them, the most mature technology is voice recognition among those things. As for near field recognition in a quiet indoor environment, the recognition accuracy can reach about 96%, which is really a good number. And I know people are consistently trying to make sure that they improve such of these technologies. According to our timetable, we are meant to have a 20 minutes break. So at this point, we are going to have a break, and then we shall return at exactly 8 to complete the rest of the class. So thank you and enjoy your break. So we had looked at voice processing application scenario, and we all agreed that we had used some of those things already. And now we want to go and look at, this is the voice processing scenario 2. We looked at the first scenario, now we're looking at the second scenario. So we're looking at intelligence, education, where we have a telephone follow-up, converts telephone follow-up content into human voices to communicate with customers. Someone calls, hello, welcome to MTN, to be able to assist you this, how could we be able to help you, things like that. So improving the overall convenience of calling customers. Then there's intelligence education, which converts textbooks where you're able to listen to audiobooks into like lifelike voices to simulate classroom teaching, to help the teachers find new and innovative ways to better the education of their students. Then we also have real-time conference records. We have conference records, like quickly identifying audio files for conference records and convert them into text for easy recording, or even real-time conference records. Nowadays, some of the courts, they don't have clerks who are going to write down things. They just put there an audio device, a recorder, you speak, and then it will directly translate those recordings into texts, which can now be easily kept as, text records from those courts. So we have intelligent education, real life, time conference records, people are speaking, and then it keeps on, capturing, maybe for those who cannot even hear, to be able to know what is taking place. Even applications like Google Meet, Zoom, where you can turn on captions for people to see the words, which intelligently converts your words into text. So this is what we are looking at when it comes to voice application. Other application scenarios like spoken language evaluation, diagnostic robot, voice fingerprint recognition, smart soundbox, and etc. So let us look at the natural language processing application scenario 1. The main topics of natural language processing research includes machine translation, text mining, and sentiment analysis. The natural language processing imposes high requirements on technologies, but confronts low technology maturity. Due to high complexity of semantics, it is hard to reach the human understanding level using parallel computing based on big data and parallel computing only. In future, natural language processing will achieve more growth, understanding of shallow semantics, automatic extraction of features, and understanding of deep semantics, single purpose intelligence, and hybrid intelligence. Can someone tell us what semantics means to them? Anyone?
Hello?
Yes, go ahead.
Like I could understand a semantic being like a diagram.
I understand a semantic being like a diagram.
Yeah, like something like, okay, a diagram showing procedures on like, okay, procedures from one step to another. Let me say, it's like it is showing steps from one step to the other like that.
Okay, thank you. Anyone with a divergent view in relation to language?
Hello?
Yes, go ahead.
I get semantics as a collection maybe of simple steps or simple techniques of understanding something, be it a language, a word, anything, but involving simple techniques and steps of understanding something.
Okay, thank you. Yes, so basically semantics here, or what we're trying to refer to, basically the meaning, the study of words and sentences. If we put these words together, what does it mean? Or what is someone trying to communicate? So it is the simplest, like those steps you have said. It's concerned with the relation of linguistic forms to non-linguistic concepts and mental representations in order to explain how sentences are understood by the speakers of a language. So if I see a sentence, you need to be able to, if we speak the same language, there's a way you're going to be able to understand it to mean exactly what I intended to communicate to you. And this is what we are looking at here. So that's why we're saying that due to high complexity of these kinds of steps, different languages have their own way of constructing sentences and putting them together. So it is hard to reach the human understanding level using parallel computing. Application scenario, we have public opinion analysis where, people, you're in a conference and, someone explains for you. We have emotional analysis, information distribution, trend analysis, and then evaluation analysis. So, okay, I think that is natural language processing. Here you say that when, let's say this is an example of evaluation analysis, and this guy, I know you can't be able to see this, but this is reading the mobile phone has a long battery standard life, and then the user will either be, it will detect that you're talking about battery life and long battery life, so it is a happy. And when the user says that the mobile phone is poor in photography, then it will know that the camera of photographing is bad. That's why you see that system automatically put there a sad emoji. And the mobile phone is cost effective. I will select it again. Then it means they're talking about cost. So it has to do with something dealing with price. So this is the scenario number 2, machine translation. Where you can be able to translate to different languages and also be able to understand economic and what it means, and other applications like the knowledge graph, intelligence copywriting, and also video subtitle. Intelligence copywriting, like YouTube uses some algorithm. When you put there a song or a video, which has words that were copyrighted by someone else, the system will automatically detect that your video is violating copyright, and then they will send you a message to that effect. Application field, AI application field in healthcare. Hope has already told us some of the ways. Maybe Hope, you can tell us again, how do you apply artificial intelligence in healthcare?
Are you saying me? Hello?
Yes, Hope.
Yeah, so yeah, like in healthcare, it can be in very many different ways. Let me give you an example, maybe of, for example, like in sanitation, you can use it to predict cholera. You can use it to predict cholera cases. For example, Ebola. We were using it to predict where Ebola cases were when there was a big Ebola outbreak in what? In West Africa. Then you can also use it to predict maybe a skincare disease. For example, you can use your phone to scan, then it can tell you what skin disease you have and recommend where you can, what medicine you could put. So basically what a physician does, you can do it with a computer.
Okay, thank you. I think Hope has explained most of these things here, like medical image, virtual assistants, assistants for medical research, hospital management, etc., etc. So AI can also be applied in healthcare. It can also be applied in smart homes, and based on Internet of Things technologies, a smart home ecosystem is formed with hardware, software, and cloud platforms, providing user personalized life services and making home life more convenient and comfortable. Control smart home products with voice processing, such as air conditioning, temperature adjustment, switching on TVs, or etc. Basically, this is how you can be able to control. So set the temperature to 26 degrees, and then the system will go ahead, or maybe, and then it will even give you feedback. Okay, the temperature has been set, and then you enjoy your smart home. In retail, maybe people working in supermarkets or retail shops, AI will bring revolutionary changes on the retail industry. A typical symptom is unmanned supermarkets. For example, Amazon Go. Amazon Go has an unmanned supermarket, and it uses sensors, cameras, and computer vision and develop learning algorithms to completely cancel the checkout processes, allowing customers to pick goods and just walk out. You walk in, they already access, your payment details and how you're going to be able to pay, pick whatever you want and go out. And they're using artificial intelligence to be able to make that happen. One of the biggest challenges for unmanned supermarkets is how to charge the right fees to the right customer. So far, Amazon Go is the only successful business case, and even this case involves many control factors. For example, only Prime members can enter Amazon Go, and other enterprises to follow the example of Amazon have to build their membership system first. So as long as you're a member, they know your payment details, walk in, pick whatever you want, the system and computer vision, they're detailing, okay, he has picked maybe 4 packets, and this is how much we should charge him, and you don't have to talk to anyone, walk in, pick whatever you want, move out. Then the system automatically builds you. So AI, autonomous driving. We have watched so many videos about autonomous driving, but the Society of Automotive Engineers, the SAE in the US, defines 6 levels of driving automation ranging from 0 fully manual to 5 fully autonomous. L0 indicates that the driver of the vehicle completely depends on the driver's operation. The L system above L3 can implement the driver's hand-off operation in specific cases. L5 depends on the system when the vehicles are driving in all scenarios. Currently, some commercial passenger vehicles models such as the Audi A8, Tesla, and Cadillac support L2 and L3 advanced driver assistance systems. It is estimated that by 20, of course, we are already in 2021, and we have seen more vehicles that have emerged with further improvement of sensors and vehicle-mounted processors. L4 and L5 autonomous driving is expected to be first implemented on commercial vehicles in closed campuses. A wider range of passenger vehicles require advanced autonomous driving, which require further improvement of technology, policies, and infrastructure. It is estimated that L4 and L5 autonomous driving will be supported by common roads in 2025 to 2030. These are some of the things. There's a video. I don't know if I can be in position to play some that video. Maybe I'll just share the link for you guys, for those who would be interested to later on go ahead and go through it and understand some of those things and how they work. Okay, I think I want to get time to play that video now. Okay, let me see, just a moment. Let's see how long it is. Minimize this, come here. It's on YouTube, so definitely follow, send the link. And wow, these guys, so everything had to be in Chinese. Okay, I think we shall look for the English version. Apologies. Since we don't understand Chinese, let us now move to Huawei's AI development strategy and try to understand what it is and what they have in stock for us. So let us look at it. So Huawei's full stack, all scenario AI portfolio. This is their full stack, product, and it was Huawei announced that it will be open source, that the server operating system, or by December 31st, 2020. And the standalone database and online processing database by June 2020, and Mindspo all scenario AI computing platform in the first quarter of 2020. When they say full stack, for those of you who are full stack, web developers, what do they mean when they say full stack? Can someone tell me what they understand when you hear the word full stack? Before you proceed, briefly.
It means like someone developing both backend and front end.
Developing both back end
and front end.
And front end. Well, basically that someone has the knowledge to, to cater for all that is involved as far as web development is concerned, right? Like you would hear that something like full package. I can be able to do for you, considering I can look at the back end, I can also look at the front end and give you a good looking website at the end of it all. Here we are looking at full stack, which combines most of Huawei's technologies to deliver to you artificial intelligence. And it refers to their technical function. Full stack portfolio, it includes chips, chip embedment and training and interface framework and application enablement. By all scenarios, Huawei means different deployment scenarios of artificial intelligence. That means they look at the public clouds. I don't know if they mentioned them here. They look at the public cloud. They look at the private clouds. Let me just write them down for you. They look at the public cloud. They also look at the private. They look at the private clouds. They look at the edge computing. Those of you who did cloud computing, you must be familiar with edge computing, and in all forms. They also look at IoT things and consumer devices like smartphones, etc., etc. So as the cornerstone of Huawei full stack AI solution, Atlas, they have their product called Atlas. Atlas is provides modules, cards, and server based on the Ascend AI processor. They also have a processor which they are calling, this is Atlas. They also have the Ascend AI processor, which will enable their consumers or their customers meet most of their computing requirements in all scenarios. Okay, so these are can be deployed in private, public cloud, edge computing, and industrial IoT things. So the application enablement, it provides end-to-end service model alerts. These are, layered APIs and pre-integrated solutions, end-to-end, basically. Mindspore here, it supports the unified training and interface framework that is independent of the device, edge, and cloud. It is independent of those. Whatever, whether you have put it on the private or cloud, you can still be able to train your platform, and you get the best out of artificial intelligence. We have the CAN, which is our chip here. And we said it is a chip which operator library and highly automated operator development tool. And Ascend, we said it's a Huawei's CPU or processor chip that provides a series of NPU IPs and chips based on unified scalable architecture. And here we have Atlas. Atlas is it enables all scenario AI infrastructure solution that is oriented to the device edge cloud based on the Ascend series AI processors and various product forms. So this is the full stack of Huawei's scenario portfolio, looking at all those devices. Huawei's all scenarios indicates that different deployment scenarios of AI, including public clouds, private clouds, edge computing in all forms, industry of IoT, and other consumer devices. So full stack model alerts, we talked about model alerts, full cycle AI workflow. This is their full cycle. First, we have AI data framework, and it accelerates data processing by 100 folds. After that, we have visualized workflow management, which makes development worry-free when you're working with your development. They also have distributed training, which shortens training from weeks to minutes, and also one-click deployment on device, edge, or even the cloud. So it supports various deployment scenarios. And also the model alerts is automatic learning, which enables you to start from scratch. And AI sharing platform, this builds internal and external AI ecosystems for enterprises. Virtualized workflow management, you have version management, traceable, and worry-free development. And here, this is where we look at these different model alerts. But basically, you have your data. From your data, you have your AI data framework, and you have efficient filtering and semi-automated labeling and data processing, which efficiency helps you improve by 10 times compared to other technologies available in the market currently. We move now to algorithm development. And here it is just out of the box because the development is environment is compatible with mainstream frameworks like the Moxing. I think this is popular in China, simplifying model development and built-in algorithms improving development efficiency. Then from after you coming up with your algorithms, now we need to train our machines to understand or to acquire that knowledge. So distributed training, shortening the time because they're leveraging on the capabilities of the cloud, edge computing, and other devices and their technologies. It helps us to shorten the period from weeks to just minutes. And wizard-based auto learning, code-free development enabling mod training from scratch. Then after training, we deploy our deployment, and it's a one-click deployment to the device, which can be on a device, edge, or on cloud. That's why it is called all scenario deployment interface on Ascend AI processor. And then you go to the market, and AI sharing platform helps enterprises build internal and external AI ecosystems. So this is how you can apply Huawei's full stack AI things. We have the model alerts. We talked about some of these model alerts, and we said it's a one-stop development platform for AI developers with data processing, semi-automated data labeling, distributed training, etc., etc., etc. Device edge, cloud indicates devices, Huawei intelligent edge devices and Huawei cloud, respectively, whereas the online interface is a web service that synchronizes and provides an interface result for each interface request. That is AI. With automatic learning, here we said that It can be able to automate model design, parameter adjustments, and model training, comprehension, and development with the labeled data, so that you have a code-free process and requires no model development experience. So when it comes to Ascend chips, the Ascend chips for Huawei, I don't know if they're indicated here, but we talked about the Ascend AI chips for Huawei. The Ascend AI chips are designed AI chips with high computing performance but low power consumption. And the built-in AI data framework combines automatic pre-labeling and hard, example labeling to improve data preparation and efficiency by around 100 times faster. So we have the different models we have looked at, and also the different model alerts that we have looked at, and finally the market which supports that. So moving on to MindSpo, which is Huawei's AI computing framework. MindSpo. Let us look at MindSpo, full stack MindSpo. In the intelligence era, AI applications in device edge computing scenarios are booming. And AI still faces huge challenges, we all know, and technical barriers like high development costs and long development period, which hinder the development of AI developer ecosystem. As you know, the world is moving fast, and by the time you spend 2 years working on something which was relevant back then in 2018, by the time you get to 2020, you realize that actually there's something new which should actually be worked on to solve the problems at hand. So all those challenges and the technical barriers make it hard for people to continuously come up with AI solutions. The old scenario AI computing framework MindSpo is developed based on the principle of friendly development, efficient operation, and flexible deployment. In terms of deep learning framework, Huawei MindSpo is the strongest challenger to TensorFlow. TensorFlow is for Google, and we shall study TensorFlow as well in this course. We shall get into details in the coming chapter. We also have MXNet for Amazon, and then we have PyTorch for Facebook. We have PyTorch for Facebook, and also Microsoft has its. I think it's called CNTK. Yes, CNTK for Microsoft, and they're major players as far as deep learning is concerned. So MindSpo is one of their competitors, and MindSpo will be open source. It will be made open source by Huawei. It's going to be a framework which is going to compete with those likes of TensorFlow, PyTorch, Pedo, and then CNTK by Microsoft. So MindSpo provides automatic parallel capabilities with MindSpo scenario algorithm engineering, but we're going to look at these things in detail. There's a topic fully dedicated to MindSpo, so don't worry when you hear some words and they're saying what is this. Don't worry, we shall look at them in detail. So with MindSpo, scenario algorithms engineers and data scientists who focus on data modeling and problem solving can run algorithms on dozens or even thousands of AI computing nodes with only few lines of description. The MindSpo framework supports both large-scale and small deployment, adapting to independent deployment in all scenarios. In addition to Ascend AI processors, MindSpo also supports other processors such as GPUs and CPUs. So this is their all application or AI application ecosystem for all scenarios. They use MindSpo, and it uses unified APIs for all scenarios and intermediate representation for computational graph and on-demand collaborative architecture across device edge computing, which looks at deployment, scheduling, and communications. So it supports processors, the Ascend AI processor for Huawei, other GPUs and CPUs by different vendors. So let us look at the full stack CAN. And CAN is a chip enabling layer developed by Huawei for deep neural networks and Ascend chips. It consists of 4 functional modules, and we're going to look at those functional modules later on. But one, we have our Fusion engine. From the Fusion engine, we have the operator or the development tool. From the operator or the development tool, we also have the library, and then we have the compiler. So we shall look at it in detail, but it's basically a chip operator library and highly automated operator development toolkit. It's optimal development efficiency in depth optimization for common operator library and redundant APIs. Could someone tell us what APIs are for those who don't have an IT background? We may be talking about APIs, and APIs. Someone, any volunteer?
Okay, I speak?
Yes, please go ahead.
Yeah. An API is application programming interface whereby you can plug into different, you can work with different endpoints from different systems to develop one system.
Okay.
I don't know if I've summarized it well.
You have, and I'm not going to add on to that, but thank you. Remember,
it's an acronym. It is an acronym.
Okay, yes.
Hello?
Yes, Michael, we can hear you. Go ahead.
It's an acronym for application or programming interface.
Okay. All right. So we previously looked at the full stack AI all scenario for Huawei, and we looked at some of these things. This is the all scenarios where we can, deploy it on our consumer devices, public or private or edge or even industrial devices. To be able to do that, we said we can use our powerful Ascend AI, processor chip, which has all these different things mixed with it, or we can even use other, chips available. And we said we can now use the chip, the CAN chip, to enable us, because it's an enabling layer, basically designed for deep neural networks and Ascend chips to support these guys, which we can now use MindSpore, we can use TensorFlow, we can use any other framework to be able to come up and develop our different application enablement platforms or APIs, and then we come up with AI applications. So, but basically this slide is looking at CAAN, which looks at computer architecture for neural networks, and it has these 4 things. The Fusion engine basically is an operator level Fusion engine, and it fuses operators and reduces the memory transfer between operators, and also improves performance by over 50%, which is quite interesting. When it comes to the library, it is an optimized general operator library, which provided by Huawei, and can meet almost all the requirements for most mainstream vision. It looks at vision and also the natural language process neural networks. It is estimated that these libraries will be open by 2020, and I can confirm that they're actually opened. So the other one is the operator development tool, and this operator development tool is basically used as an efficient and high performance custom operator development tool. It abstracts hardware resources as APIs and enabling customers to quickly construct required operators. This functional module is expected, it was expected to be available by 2020, and it is now available to the market. And lastly, the compiler. Who can guess what does the compiler do? Okay, so let us look at the Ascend 3.10. Please do not try to cram these things. They're just opening up your mind to some of the tools available out there. I know the screen may look like it has a lot of information, but this is an example of Ascend 3.10 AI processor, and this is how it was designed. It has a performance of over 8T, at FP16, and it's an AI core processor, and this is its performance. It has 16 channel decoder. It can decode MP4s up to 1080 by 30 frames. It has the LDDR4X memory controller. The memory bandwidth is the bandwidth. It supports PCI USB 3.0, etc, etc. So I'm not going to go through this, but basically this is how it was built. It has the cube. The cube looks like that. The Da Vinci core, the ARM system cache, and this typical configuration, high performance and low power SKU can be offered based on your requirement from Huawei, and then they offer you that processor. The AI Ascend processors fusing superior intelligence for computing. This is it. And we have the mini AI mini Ascend, it has these functionalities. These materials were already shared. I'm not going to just read what is on the screen, but the Max has better functionalities, of course, as compared to the mini, because like you hear the word Max, usually these vendors usually mean something that is more powerful compared to the other versions. So basically this is the Ascend AI processor, and it is used basically to support the development of AI applications and offered by Huawei. Now Atlas AI computing platform, a portfolio powered by the Ascend series AI processors. This Atlas AI computing is powered by Ascend processors, and the Huawei Atlas AI computing platform supports rich formats, including modules, cards, edge stations, servers, and clusters. Atlas enables AI solutions for all scenarios across the devices. It could be edge or private or public cloud, and as an important part of Huawei's full stack AI solution, Atlas launches the training platform. Now, keynote, Atlas deals more with training. We said Khan deals with what? Who remembers? Who remembers? I've even given you a hint.
Khan deals with architecture and neural networks.
Architecture and neural networks. Very good. So we looked at some of those things. So Atlas, for it, launches a training platform, and it launched it in 2020, providing the industry with complete AI solutions. Huawei will also enhance all scenario development and drive full collaboration across a device, edge, and cloud, enabling every phase of AI industry chain. So these are some of the the things available. There's Atlas 900. This is how it looks like. Atlas 800 AI Training Center. And because AI uses a lot of computer resources, it requires you to have some of these things available with you to be able to design some of these things. So these are the chips and hardware, and from these you can add on top your architecture and neural network, and then you add your framework depending on whether you're going to use TensorFlow or PyTorch or whatever you feel like you want to use, or Mindspo. And then now application enablement, you can use Atlas Intelligence Edge platform, which is like an SDK or container engine, basic service repository. And then you can also use Atlas Deep Learning platform for cluster management, model management, and data pre-processing. So let us look at the disputes of artificial intelligence. You already talked about some of those disputes. I saw someone mention it in the chat. Here there's a question that's saying, seeing is equal to believing. With the development of computer vision technologies, reliability of images and video is decreasing, because now people can come up with the actual picture using artificial intelligence and actually appear as if like it's actually you there. You can even look at just the videos made on Snapchat or even TikTok. So fake images can be produced with technologies such as Photoshop and generate adversarial networks, making it hard to identify whether the images are true or not. For example, they have an example here. A suspect provided fake evidence by forging an image in which the suspect is in a place where he has never been to, or with someone he has never even seen using shopping technologies. So imagine you're in court, you're presented, and someone says maybe on such and such a day they were somewhere with someone, and they have used the technologies available, and they have developed a video that shows that that person was actually in that place at that particular time. So these are some of the disputes. In advertisement for diet pills, people's appearances before and after weight loss can be changed with these technologies to exaggerate the effects of the pills. Some people, and this could be also a point of concern. And a tool for simulating voice, Leabart is a tool for simulating voice for human beings based on recording samples of minutes and may be used by criminals. You can just record a few samples of minutes, and then this tool can stimulate someone's voice, and then you type in the sentence you want them to say, and they say the sentence, and when you listen to the audio, it actually sounds like like maybe Hope talking to us. And then household images released on rent and hotel booking platforms may also be generated through such different platforms. So there are so many disputes, and these are just a few of them. But we have so many concerns about AI and what impact it has on our society and our generations. Will machines be in positions to control us? And people also worried that recent development of artificial intelligence is going to lead to rising unemployment. And looking back, human beings have always been seeking ways to improve efficiency. That is, there's no doubt. Even back then in Stone Age, where they decided to use bones to cut and sharpen stones, and then discover iron and discovered, other things like fire, basically to improve efficiency in all that we used to do as human beings. That is to obtain more with less resources. So we used sharp stones to hunt and collect food more efficiently. We used steam engines to reduce the need of horses. And then every step is achieving automation with change in our life and work. In this era of AI, what jobs will be replaced by AI? The answer is respective jobs that involve little creativity and social interaction. So if you're having a job and you have little creativity, and there's also little social interaction, then you should be worried for your job, because in the near future, you may be jobless. But these are some of the jobs that are most likely to be replaced by AI. The courier, you've already seen Amazon using, drones and delivering packages to the intended people. Taxi drivers with these self-driving cars, that if they're able to come up with let's say nowadays, they don't need a lot of pilots. They just, send drones to go in their fighter jets and, accomplish the mission minus putting anyone's risk at hand. So if they can come up with droids, I don't know if you've watched those movies. I used to watch this popular movie. What was it? I'm forgetting its name. Where there are droids in the movie, and they used to fight for the country. Also accounting. So such jobs that require little creativity and no interaction means that you do the same things today, yesterday, and tomorrow. These jobs may end up being replaced by AI. So jobs that are most unlikely to be replaced by AI, the writer, because we said it is hard for the machines to understand the language and also to make sense out of our semantics and the different languages that we have. The management personnel, people managing people, software engineers, human resource managers, designer, and activity planner. And there's also so many other jobs that are available there. The problems to be solved: AI created works protected by copyright laws. Who gives authority to robots? Who do they listen to? What rights shall be authorized to robots? These are some of the things that you need to think about as now people who are pursuing a career in artificial intelligence. And now let us look at the future prospects of artificial intelligence. Development trends of artificial intelligence. There's a framework, easy to use development framework. You just have your framework, use it like PyTorch, and then be able to, design something meaningful that is going to help you solve your problem. Algorithm, these are models that with better performance and smaller size that will be available in the near future. And computing power, comprehensive development of device edge cloud computing, so you can use your device to use that strong complexity computations, and you're able to come up with something that is going to solve your problems. Data and the more comprehensive basic data service industry and more secure data sharing. And then scenario-based is very hard for AI, but in the near future, we suspect that continuous breakthroughs in the industry applications will help us crack down scenario-based artificial intelligence. Easier to use development framework. There are so many frameworks that are available. We talked about MindSpo. This is a Huawei's framework. TensorFlow for Google, and then PyTorch for Facebook. Various AI development frameworks are evolving towards ease of use and omnipotent, continuously lowering the threshold for AI development. PyTorch, TensorFlow 2.0 has been officially released, and it integrates Keras as its high-end API, greatly improving usability. These are some of the breakthroughs that we have so far. PyTorch versus TensorFlow. As we can see, PyTorch is widely recognized by academia for its ease of use. Many, people in the academics, in academia use PyTorch to, they have their wide range of variables, and they want to make sense out of their data, draw predictions and analysis. So it is widely used by the people in academia because it is easy to use. As you can see, the comparison between it is a solid line for this is the comparison between the use of PyTorch, which is widely used in academia, and it is easily used. Whereas in the industry, TensorFlow supports industry development better and still has a larger market share in enterprise as compared to PyTorch, which, however, shows a trend of continuous catch-up. The PyTorch for Facebook and TensorFlow for Google. So smaller deep learning models. A model is a model with better performance usually has a larger quantity of parameters, and a large model has a lower running efficiency in industry applications. More and more model comprehension technologies are proposed to further compress the model size while ensuring model performance meeting the requirements of industrial applications. So we look at low rank approximation, we look at network pruning, network quantification, knowledge distillation, and compact network design. So we have our model compression, and it's compressing all these things to help us achieve running efficiency in industrial applications. And then computing power with comprehensive edge device edge cloud development. Here we basically look at the scale of AI chips applied to the cloud. All edge devices and mobile devices keep increasing, further meeting the computing power demand of artificial intelligence. As you can see here, this is the picture, of course, taken from AI chip industry development white paper from China 2020. As you can see, there's a trend which is going from about 53 to about 57%. So more secure data sharing. Federated learning uses different data sources to train models, further breaking data bottlenecks and while ensuring data privacy and security. So we have a model A, model B, and we're training them, but now there's no data exchange here. But with this, now there's some kind of, we have federated models, and now we have now different collaborators which you can use to, collaborate data from, data model A from B, so we can share data. And then it makes, it enables us to have breakthroughs and ensuring data privacy and security through the use of sending public keys and also requiring those keys to access that data and also decrypt the data. So continuous breakthroughs in AI application scenarios. With a continuous exploration of artificial intelligence in various verticals, the application scenarios of AI will continuously be broken through, mitigating psychological problems, automated vehicle insurance, and loss assessment, and then office automation. These are some of the things that AI has been able to penetrate. Mitigating psychological problems, AI chatbots help alleviate mental health problems such as autism by combining psychological knowledge. You know those things where people listen to. This is a popular app, my AI friend Replica, which talks to you and helps you calm down. Calm down. You are strong. You are wise. Wake up today, ready to face your challenges. So things like that. So these are some of the the future trends of AI. And then automatic vehicle insurance and loss assessment. Some companies use AI technologies to optimize vehicle insurance claims and complete vehicle insurance loss assessment using deep learning algorithms such as image recognition. As you can see in this image, these guys were able to tell that, basing on this, the computer will study and learn the different types and how the car looks, and to be able to tell that either this person was, the one in wrong, or this person knocked them at this time, or this and this. And so therefore, we can come up with a conclusion that this person needs to be reimbursed this amount of money based on the evidence provided. So it helps in vehicle damage assessment. And then office automation. Of course, AI is automating management, but the different nature and format of data makes it challenging tasks. Some people have papers they sign on. So while each industry and application has its own unique challenges, different industries are gradually adopting machine learning based workflows. They have different tools that they're using for collaborations, emails, Zoom, etc., which will be easy for automation of management. So this takes us to the summary page, and this chapter has introduced us the definition and development history of artificial intelligence. It has also described the technical fields and application fields of artificial intelligence. Briefly, of artificial intelligence, briefly introducing us to Huawei's AI development strategy. And finally, we have discussed the disputes and development trends of artificial intelligence. So let us look at this quiz, and we try to, tease our brain and see if there's some little bit of learning which has taken place. So let me ask with point A. Unfortunately, I don't have, let me see the time. We have 7 minutes. Okay, let me see here if I can. Okay. It was not enabled on this account, but I should have popped up the quiz. But since it's not enabled on this account, and it will take us a lot of time, let us leave it for now. But let me ask now. Let me ask question number 1. Which of the following are AI application fields? Maybe you could just, I don't know how best. Come again?
All of them.
All of them.
All of them.
All of them. A, we apply AI. B, we apply AI. C, we apply AI. And also D, we apply AI. So all of these qualify. Then question 2, we are determined to see if it is true or false. By all AI scenarios, Huawei means different deployment scenarios for AI, including public clouds, private clouds, edge computing in all forms, industrial AI to things, and consumer devices. Is this true or false? Can we just post in the chat and see?
True.
Okay, Gertrude is saying true. Martha is also saying true. Chiemba Ismail is saying true. and Nathan and Andile and Alex. So yes, we already said that by OS scenario, AI, it can be, deployed in different scenarios, including public clouds, private clouds, edge computing, in all forms of industrial IoT devices and also consumer devices. So which gives our answer to be marked as true. So for more learning, you can visit these links here. We'll share them later. And thank you for being part of today's class. We shall meet again tomorrow, same time.